Hey everybody, I found a problem similar to this in a document produced by Evan Chen, an IMO Gold Medalist, and he claims that this came from a Stanford math competition all the way back in, I believe, 2011. I don't know what problem number it was, but it was some sort of math competition held at Stanford, I believe. And anyway, you can see this is a infinite series with a fractional piece here that's going to just get smaller and smaller and smaller. And so the question is, can we show that this converges, and can we find out what does it converge to? Well, a standard idea here is just to do the partial fraction decomposition of the summand. And that's very easy to do by inspection. No need to get too formal about it, but this is partial fraction decomposition. You see, and you can actually just n squared plus 2n is n times n plus 2. Okay, so you can do this just by checking it. There's no need to, again, to spend too much time on it. Partial fraction decomposition. All right, now anytime you have something like this that's a difference of two rational expressions, you have a chance for it to do something called telescoping, where a bunch of the terms cancel out in a masked sort of fashion. Okay, so this is a partial fraction decomposition. You can check real quickly that n plus 2 times 25 is 25n plus 50. Then when you subtract 16 n, you get, this is what you end up with, 9n plus 50. It's very, very easy to verify, okay? So rewriting this, this is the part that's kind of hard from a competition point of view. We would like to get these two objects to look as much the same as possible. Well, it turns out that 16 is equal to 4/5 squared times 25. This is easy to verify too. 5 squared is 25. The 25 is canceled. You get 4 squared is equal to 16. And so this partial fraction decomposition becomes this, okay? Now remember, this partial fraction decomposition is equal to the original summand up here, okay? So now we want to make it look like the original problem, right? So we multiply through by 4/5 raised to the nth power, and we get this. Here's your original. And this is what happens when you multiply the original partial diffraction composition by 4/5 raised to the n, all right? Notice that it increments this. This was already 4/5 squared, right? So if you multiply by 4/5 to the n, you would have 4/5 to the n plus 2, okay? Now, there's probably ways to do partial sums here, but I just wrote out the first few terms. You know, there may be a very formal way to do it, like partial sums, take the limit as n approaches infinity. But anyway, I just decided to do it case by case. So let's just look. For n equals to 1, this would be the first summand right here, and you guys can check. I've double checked this, so I'm pretty sure I got them all right. N equals 2, you get this summand. N equals 3, you get this summand. N equals 4, you get this summand. All right. Now I've tried to color code it. You can see that everything is, the stuff that cancels is separated by 2, which is no surprise because you have n plus 2 right here. All right. So you see how the reds cancel, okay, and the greens cancel. And so you see how this telescoping business is going to go. And just to be sure, what's going to be left right here, I'll just do the first part for 5. Notice that for n equals 5 right here, okay, what are we going to get? We'll get exactly this term that hasn't been canceled out yet, except it'll be the plus version. So we would get 25 over 5. Notice, y'all, I didn't simplify anything. There is absolutely no need to try to simplify these numbers and write them, you know, as Hindu Arabic numbers, okay? It's just important to see what they are and how they offset each other. So you got 25 over 5 times 4/5 raised to the 5th power as the first term. And you can see I'm just substituting right here, right? I didn't do the second part, but you have 4/5 raised to the 5th power. And you see how this part, and this is just part of it, right? There's something else here, but I won't even write it down. So now this one will cancel with this one. You can see how this pattern is going to continue ad infinitum. Notice I put the ellipsis right here. So the only two things that are surviving, you see in this process, the only two values that survived are these constants in the very first two terms. You see, the mass cancellation didn't start happening until kind of late in the game because everything is spaced by 2, right? Okay. So in other words, the sum of this value and the sum of this value is going to be your answer here because everything else mass cancels. So what do you get right here? 25 over 5 is 5 times 4. So this would be 20. And y'all, I'm just summing up. Or I'm just 25 divided by 5 is 5. 5 times 4 is 20, right? Now what about right here? You have 25 over 5 squared, which is just 1, right? And then you have 16 over 2, which is 8. So this would be plus 8. And again, y'all, I'm just adding up these two underlined terms, all right? This is the only pair of survivors, if you will. Nothing offsets these because of the spacing of 2, owing to this n plus 2, okay? So anyway, the answer to the problem is 28 without taking any limits or doing any partial sums. All right, so that's it. And again, I just summed up the two terms that survived this mass cancellation process. So let's just go back up here. So this is equal to 28. Okay, y'all, that is it. Let me go back down here and check. Yeah, it's looking good. 28. Yep. Okay. Thank you all for viewing. Good night.